Welcome to Ethical Engineer YouTube channel. Uh, in this Ansys basic level training program, in today's session we are going to talk about why the model analysis is so important to run before any analysis system. Normally, if you are taking the analysis system in Ansys workbenches, there are a lot of analysis systems there, and we have seen this in the first class itself. Uh, in structural analysis, there are a lot of structural analysis there. Normally we perform the static structural analysis, and we perform the random vibrational analysis, and we perform transient analysis, uh, response spectrum, all those things, the rigid dynamics analysis, all those things we are. There are a lot of other structural analysis system is there, but in industry, before performing this any analysis system, normally they will run the free run, that is they will run the model analysis first. Okay, even if you're performing any nonlinear problem or dynamic related problem or explicit analysis, the first thing in industry what they do means, like, once you make up the model, before proceeding for the particular type of analysis, before going for a buckling analysis or any other type of analysis system, the first thing they will do is like to prefer to analyze the model in the free run. Okay, that is they perform the model analysis at free condition. Okay, why they are doing that? Okay, what is the importance of running the free condition? So these are the things we are going to discuss in this today's session. Okay, so what I'm going to explain about in this session is first we have to understand what is modal analysis itself. Okay, the modal analysis is nothing but we have to carry out this type of analysis to know the natural frequency of that structure. So for example, if I have the cantilever beam, I just want to know what was the natural frequency of this structure. Means what I have to do is, like, I have to perform the modal analysis for this cantilever beam. Okay, once I will perform this modal analysis, I will get the frequencies, I will get the mode shapes of the structure, what are the mode shape is available, and what was the frequencies required to uh, required for that structure to oscillate particular to the that mode shapes. Okay, so why that I will explain later on, why that first we have to find out the natural frequency and all. Okay, that topic is separate. Okay, uh, when we go deeper towards the model analysis, I will explain that what is the purpose of finding the natural frequency and why it is important in dynamic analysis and all. Okay, for today's scope, it is why the model analysis is very important to run before any analysis system. Okay, so for example, for this uh, the cantilever beam itself, if I before running the static structural analysis, it is better to run the model analysis. So this is what the industry is proposing. Okay, now I'm going to explain why this is very important. The first thing is, in order to check the boundary conditions. Okay, so in industry they run the model analysis before. Why? Because they have to find out whether we apply the boundary condition correctly or not. So the first and foremost thing is the boundary conditions. uh, Whether we apply the, if you apply the proper boundary conditions, or while running the model analysis, it shows that, if you are not applying any boundary condition, and if you run the model analysis, then it shows the first 1 to 6 mode shapes are rigid, that is, will get zero frequencies for first 6 modes. Okay, and if you are having the constraint, that is, for all the 6 degrees of freedom is arrested in any one point. For example, for this cases is for this cantilever beam, if I run this model analysis, I am not getting the first 6 nodes or 0. Why? Because I arrested 6 degrees of freedom at one end, so I will get some mode shape from 1 to 6. Okay, if I'm not arresting in one side, then I will get first 6 nodes will be 0, and then from sound to modes onwards I am getting the frequencies. Okay, so in industry they will run the free analysis for a structure. uh, why? Because to understand what type of boundary condition they are given, whether they give the boundary condition properly or not. In order to check that, they will run the free analysis. Another one, the main important thing is the second thing. It is not a second thing, it is the foremost thing. To check the contacts. Okay, so to check the contacts, it is very important. For example, if you are having the complex geometry, and it has a lot of surfaces. Okay, so from one component to one component, if there is connection is there, that is, if you are having the mesh continuity, if you are not having mesh continuity, means then what will happen, mean even though if you are applying even though if you are giving the boundary conditions properly, and if you are having first 6 nodes or 0, okay, then means there is not a connectivity is not present. Okay, and if you are not applying any boundary condition, and you run for 12 modes, and the first 12 modes are 0, means what happens, the first 6 modes are 0. Why? Because you have not applied any boundary condition, and the other 6 other 6 modes are 0. That means the first 12 modes are 0, means then there has to be a serious continuity problem in your system. Okay, so that you have to look into that structure, and you have to see that, you have to fix that, the if there is any gap is there, or if there is a contact is there, means you have to make sure the contact is perfectly happened, and the mesh continuity is there or not. Okay, so these are the two important things. For these things only we have to run the model analysis before any analysis system. Okay, so as of now, I generally said that, so boundary condition checking, we are analyzing the model analysis, and to check the proper connectivity, we are running the model analysis, right? So I'm going to demonstrate that what will happens. Okay, so will real-time applications, I'm going to run the some of the I'm going to take two things. That is, the first example, I'm going to uh, analyze the crankshaft. Okay, I'm going to analyze the crankshaft. Okay, in that what I'm going to do is I'm going to apply different boundary conditions. Okay, and different boundary conditions, and I'm going to uh, check which one is the proper boundary conditions. Okay, so the first thing is I'm going to open the workbenches, and that I'm going to select the model analysis over here. Okay, in that what I'm going to do is I'm going to import the geometry. I'm having the whole engine setup over there, so I'm going to edit the geometry in space climb. In that I'm going to select only the crankshaft, because I'm as of now I imported the step file of the whole engine setup itself. So what I'm going to do is I'm going to uh, select only the crankshaft model, because I'm going to analyze that particular part only. Okay, so now that geometry is imported, and now you can see the whole diesel engine here over here, but as of now my interest is to look for only this crankshaft. So I'm going to suppress all the components. So by pressing the shift key from top to bottom, right click, and click for suppress for physics. That means I'm not going to take this component as the for analysis purposes. Okay, so except crankshaft, I'm going to suppress all the component. Okay, now in geometry I'm have only the crankshaft alone. Okay, so I'm going to close this space clamp, and I'm going to open the mechanical structural workbenches. Okay, as of now I'm going to deal with the structural steel itself. I'm going to apply the whole geometry as a material as structural steel. Okay, by default material. Okay, once that geometry has been imported in the mechanical structural, uh, I'm going to perform I'm going to apply different boundary conditions, and I'm going to get the different mode shapes. Okay, by seeing the mode shape you can judge whether the applied boundary condition is correct or wrong. Okay, so what I'm going to do is I'm just giving for meshing, I'm going to give the rough mesh. So I'm going to give some element size is 15 mm. I'm going to give the automatic mesh. Okay, so the structure is meshed now. Okay, so now I'm going to perform the model analysis. You can see this in the analysis settings. By default the maximum nodes is 6. I'm going to increase it to 12. Okay, now I'm not applied any boundary condition. I'm not giving any fixed support or any other support over here. Before now, without applying any boundary condition, I'm going to run the analysis. Okay, you can see the solution is taken. You can see that since I'm not applied any boundary condition, you can see the first 6 nodes, right? You can see the first 6 nodes, it is giving 0. Okay, so that means uh, we are not applied any boundary conditions. If you see in the normal mode analysis and the first 6 modes are 0, means that means you are not applied any boundary condition. You are not applied any fixed support or any other support over the geometry. Then only you will get first 6 modes are 0. Okay, so now I'm getting this 6 nodes are 0. Okay, now what I'm going to do is now I'm going to apply the boundary conditions. Okay, so I'm going to right click and clear generated data over here, and in model analysis I'm going to give fixed support. Okay, the fixed support, what I'm going to do is like this crankshaft, right? So this shaft should be rotated over about x-axis. The x-axis it should be rotate. Okay, then only we can have the piston movement and all. It will fire. Okay, that is based on the firing order only. Like while rotation of this crankshaft, the piston shaft crankshaft based on the rotation, the piston movement will be there. Okay, so now what I'm going to do is I'm going to do simply the at this end and this end I'm going to apply the fixed support. Okay, but actually this is not a correct support. Okay, I will explain that also. Okay, as of now I blindly given the fixed support over here, and I'm going to solve the problem. Okay, so even so the model analysis is very important is by seeing the mode shape you can understand whether you apply the boundary condition correctly or not. Okay, so you can see that now what I'm going to do is I'm going to expand all the mode shape over here. Okay, so what I did is in solution uh, I extracted all the modes. Okay, so I'm going to evaluate all the result. Okay, so you can see that in first mode shape I'm going to play that animation. You can see that the first mode itself, you can see that this is the movement is that software is generating, but actually this type of movement is won't take place in the crankshaft. Okay, so why? Because this is the first mode first 3 modes itself you can understand whether you apply the boundary condition properly or not. Okay, so here I just applied the boundary condition is fixed support, and I'm getting the first mode is this type of movement. So this type of movement is not a possible movement in the crankshaft. Okay, so that means obviously the applied boundary condition is wrong. Okay, so what I'm going to do is I'm going to correct this boundary conditions. Okay, so I'm going to right click and clear the generated data, and instead of fixed support I'm going to apply different boundary conditions. Okay, so why this is fixed boundary condition is wrong means like this shaft should be rotate. If I give the fixed support means then it may not be rotate, right? So that's the reason. So it gives the wrong value. So what I'm going to do is like normally uh, if you have this crankshaft, what will happen means the here and all you have the supports will be there. Each and every shaft are having these supports, and this should be free to rotate also. So I'm going to give the frictionless support over here. You can see that the frictionless support. Okay, right click on the model, insert, and I'm going to give the frictionless support. Okay, so I'm going to give this frictionless support over here, this option. So this is where the support is located. Okay, and I'm going to apply frictionless support. Okay, you can see that what is the mean by frictionless support. If you see click on here that it has a pop-up message, that is it will prevent one or more or flat curves from moving or deforming in the normal direction. In normal direction it will resist the movement. This is what it indicates. That means it can able to rotate, it can allow the rotation. That is what it mean by. Okay, so as of now I apply the frictional support and I'm going to run the analysis. Okay, so now uh, the frictional support is nothing but like it can able to see, you can see that first two nodes are 0. Okay, the first two modes are 0. Why? Because uh, the frictional support, it's not arresting all the degrees of freedom. So uh, it will resist only the other direction, that is normal to that faces only it will resist, but other rotation will, it won't be resist. That's what we are having, the 2 degrees of freedom are left over. So we have that first two modes are 0. Okay, so previously if we see that when we apply the fixed support, we have from first mode onward we are having the frequency, and first two modes, first six modes are we are having the frequency. But whenever we apply the frictional support, what will happen is like the first two modes are 0. Okay, that means this also is not a good way. You can see if we apply the first two modes, you can see that so the crankshaft is rotate, but it will see that there is a expansion in the lengthwise. You can see that. So it is rotating, but there is a expansion in x-wise is there. So this type of modes also not a possible. You can see the second mode, it is moving in this way. This also is not a proper way, right? So the crankshaft is won't move in this lengthwise also. So what I have to do is like I'm going to uh, again I'm going to give the boundary conditions properly. So what I'm going to do is so in first two modes the rotation is there. So we given somewhat half away is a good boundary condition we applied, but the thing is it is expanding in the lengthwise, so we have to uh, give the proper boundary condition over there. So I'm going to give the displacement boundary conditions. So I'm going to arrest the displacement over here, that is displacement of lengthwise. I'm going to arrest at the two end phases. I'm just giving the displacement boundary condition, and I'm going to in xyz I'm going to just give the value of 0 and 0 and 0. Okay, so now I given the displacement boundary conditions in to restrict the motion of this crankshaft in lengthwise. Okay, so now I'm going to solve the problem again. So you can see that in first mode, okay, I'm getting the 469 hertz. Okay, so and I'm going to play this animation. You can see that uh, there is a rotation of the crankshaft is there, and there is no motion. There is a lengthwise, there is no movement. Okay, and in second way also you can see this. So this is the proper boundary conditions. Okay, so by seeing the all the different modes, by now we can able to see that what are the possible way of movement is happen based on uh, uh, the boundary condition we are given only it will shows. Okay, so as of now what we did is like I given the frictionless support and I restricted the crankshaft movement in lengthwise. So this is that somewhat somehow it is a correct boundary condition, closer boundary condition for the crankshaft. So we can see this type of motion. Okay, so this is how that modal analysis is very important before performing any static structural analysis or dynamic analysis. Okay, so we can check whether we applied boundary condition is correct or wrong. That is one thing. That's what we demonstrated over here. Okay, and then uh, if you are not giving proper boundary condition, that is if you are not fully fixed the conditions, means like you can see that initially I'm not given any boundary conditions, I'm getting 6 modes or 0. Okay, and I given only the frictional support and I'm getting first two nodes are 0. When I apply the fixed support, I'm getting all the modes. Okay, so like that based on your boundary conditions, that modes we are getting, right, it will be differ. Okay, so by seeing the modes of first modes or second modes, we can judge that whether we give the proper boundary condition or not. Okay, so it is very important. So this is one thing. Okay, so now I'm going to demonstrate the second example. Okay, in second example is like I'm going to analyze the structure of a chair. Okay, in first class I demonstrated how to create a chair in a space climb. Okay, using pull option, move option, all those things, I demonstrated how to create a chair, simple normal chair. Okay, now what I'm going to do is like I'm going to analyze that three-dimensional chair into by converting the whole three-dimensional structure into two-dimensional, and I'm going to do a one-dimensional analysis. In a combination of 1D and 2D, I'm going to analyze those chair. While performing that conversion from 3D to 1D and 2D, we may miss some of the contact regions, all those things. Okay, so while I'm going to explain those things now, so in this itself I'm going to create another model. Okay, in that I'm going to import model of the chair we have already created. Okay, so for you I'm just going to open the space climb. Okay, so in that space climb itself, what I already did is I created the whole chair, and I extracted the mid surfaces and beams. Okay, all those things I already did it. Okay, you can see this, this is the solid one. Okay, this is that solid chair I made it. And then what I did is I right click the solid and make it as suppress. Okay, why? Because I'm not going to analyze the chair in the 3D model. I'm going to convert into 2D and 1D over here. Okay, so what I did is like so this is how I did it. Like I've taken the mid surfaces of the solid structure, and I converted uh, this each and every legs as the by extracting this option, I extracted the 1D beams. You can see the beam, this extracted profile is there. So I already demonstrated how to extract the 3D from one dimensional element in the previous lessons and all. Okay, so I I taken the this mid surfaces, and I taken the extracted these things. As of now you can see this is the solid whole solid structure. Okay, so as of now I'm going to analyze this structure. Okay, so I'm going to close this axis plane. So I'm going to open this mechanical model. Okay, see in this chair structure, if you see that we have two-dimensional surface and we have one-dimensional beam element. Okay, and since we are extracted from the legs, the cross section is already extracted, so those dimensions and all taken from the three-dimensional solid. Okay, you can see that here. So as of now I didn't do anything. Okay, so what I'm going to do is like I'm going to just going to give the fixed support over here. I'm going to assume that at bottom this legs and all fixed. Okay, in my assumption. So I'm just going to select the vertex, and I'm going to select this point by selecting the control option. I'm selecting the 4 points, and I'm apply the fixed support at the bottom of the legs. Okay, and in analysis system I'm going to choose 12 mode shapes, and I'm going to run the structure, run the analysis. Okay, if you see that first 6 modes are present. So you can see that first 6 modes we have the frequency. Okay, that means while doing the 2D and 1D connection, you can see that it is properly connected over here. Even if you see the mesh and all, you can see that at the center of the node only the beam element is presented, so that we have the proper connection over here. Why? Because I make the extracted the structure in a way that I can get the proper connection. Okay, now what I'm going to do is, like, I'm going to demonstrate the uh, other way of extracting these things. Okay, so just think, like, I'm going to reopen this in the space climb. Now what I'm going to do is, like, this mist surface and the beam center I already created. Now I'm going to once again I'm going to do all those things. I'm going to delete these things and I'm going to active for physics now. So this is that whole three-dimensional structure of this chair. What I'm going to do is, I'm going to uh, perform the I'm going to convert this as a 2D and this legs and all 1D. Okay, in order to do that, I'm going to take the prepare option in that mid surfaces. I'm going to select this top surface and bottom surfaces. Okay, so once I given the top and bottom and I click this icon, you can see that mid surface is created. Okay, see, the mid surface is created now. Okay, now what I'm going to do is, I'm going to create the leg portion. So for that I'm going to extract this option. I'm going to select this solid. Okay, make this solid present and I'm going to select this legs. Okay, as soon as I select this leg, I can see that the beam is extracted. Okay, the first beam is this one, second beam is this leg, and third beam is this one, and fourth beam is this one. Okay, now I extracted the mid surfaces as well as the beam. Okay, now what I'm going to do is, I'm going to, if you do in this way, I can see that there is a hole is there. Okay, and there is a 1D element is there. Okay, this is how your normally people will do. And if you close this exist option, okay, and I'm going to open this mechanical model and I'm going to whatever the changes I made in the geometry, now I'm going to again importing the updated geometry in the mechanical workbenches. Okay, so why I'm doing this means, I'm just going to demonstrate what type of mistake that people might do while extracting the surfaces from 3D and while extracting the 1D from the three-dimensional one. Okay, as of now we did like that. Okay, so what we'll do means, like, right click and give the generated mesh. Okay, so you can see that we given the, as soon as I apply the generate mesh, you can see this mesh will be like that. Like, for 2D we it automatically given the thickness, and based on the cross section the one dimensional element are meshed and we see this cross section. But you can see that in the chair and the wherever we the place we sit, we apply the load, you can see that there is a hole is there. Okay, hole is there. Okay, and what I'm going to do is, I'm going to apply the fixed support over here. So for this I'm going to select the vertices, that bottom 4 points, by pressing the control option, and then in analysis system I'm going to extract the 12 modes and I'm going to run the analysis. So you can see that now the analysis is run, but you can see that in the frequency. So the first 6 are 0. Okay, now what I'm going to do is like I'm going to remove the fixed support. Okay, I'm not going to apply any fixed support over here. I'm going to rerun the analysis. You can see that now I'm not applied any boundary condition, but you can see the first 12 nodes are 0. Okay, and if I apply the fixed support, you can see that now I apply the boundary condition. If I run this analysis, now only the first 6 nodes are 0, and we are getting from 7th mode onwards we are getting some frequencies. Okay, now still the 6 nodes are 0. Why? Because of this continuity error. Okay, this 1D element is not anyway, it's not connected with this two-dimensional structure. This is what that structure is. Because of that we are getting this type of problem. Okay, so earlier I did the proper connections, so we are getting the uh, first 6 modes onwards we are getting this result. Okay, but since here in this problem we are not getting the result in the first 6 modes. Why? Because there is a continuity problem uh, between this 1D to 2D. Okay, so that was the problem. We can fix this by what I'm going to do is like I'm going to edit in the space climb. See, in this what I'm going to do is like I'm going to uh, prepare or repair option. Okay, you can see this option called missing faces. If you see the missing faces, you can see that it shows this red color, right? Whatever the red color it shows, it all indicates these are the missing faces. Okay, so this whole center it's a missing faces, but actually when you're taking the mid surfaces, this hole should not be present, right? Okay, but if you click on this tick option, what will happen means like you will get this type of things. Why? Because in missing surfaces this thing is selected, and all the holes are selected. We have to exclude this outer area, so that means we have to make sure exclude problem. So we have to click this option and we have to click this red line first. Okay, so now this red line becomes the green one. So the only problem area is this are the red line shown here, and if you press the tick option, now this hole is patched. Okay, now what I'm going to do is I'm going to exit from the space climb now. Okay, and I'm going to enter into the mechanical workbenches. So whatever that changes I made in the uh, geometry, now in this system it will be rectified, and whatever the changes I did it right, it will be updated in the mechanical workbenches. Okay, so now you can see this, it is updated over here, and then again we have to do the generate mesh option. Now we did the meshing. Okay, so now for this I'm going to run the analysis. You can see that again we are having the, since we are close to this faces, again we are having the 6 modes or 0. Okay, so what was the reason? You can see that the reason is like still the surface is not shared with this here. Okay, so we can see that in the mid surface of this thing it should be closed. Even though if you close this thing by seeing the mesh, you can see that the continuity, right, that we have this rod is over here and it is not connected over here. Okay, so what we have to do is, again we have to remodify this in the space climb. Okay, I'm opening the space climb. So what I'm going to do here, it is I'm going to use the option called move, and I'm going to select this thing, and I'm going to move this structure. So not move I'm not going to fully move this full structure, I'm going to move this point. Okay, in move option I select this point, and I'm going to select this blue color icon, and I'm going to select up to, and select this. Okay, now I've just to move this length here up to this point. So like that I'm going to select for other option up to this. Okay, so this is how I'm going to do for all these three, and up to this faces. Okay, now you can see this, the line is at the center of this hole. Okay, this is one part, and what I'm going to do is in the system, in share topology, I make sure it is share is option is there. Okay, and then I'm going to exit the space climb. Okay, and I'm going to open the model. Whatever the updation I did it, I'm going to update in the mechanical workbenches as well as. Okay, so here you can see that it is updation is taken place. Now what I'm going to do is, like, I'm going to do one more option, that is I'm going to give the connection. I'm going to give the manual contact region over here. Okay, so the manual contact region is like okay, uh, that is I'm going to select this vertex over here, that is the contact point. Okay, before going for the contact region, we'll just run the analysis one more, we'll see this. Okay, now we give the mesh option. Okay, so you can see that in that box we are having the triangular one, and if we run this analysis, now you can see that first 6 modes are having these things. Okay, so I'm not giving any contact over here. Why? Because suppose in the space climb, in that option, that is share topology, if you're not giving that share topology, you might be given contacts, manual contacts uh, over here. Okay, if you missed to give the option called the share topology. Okay, but since I'm given the share topology over there, so no need to give separate contacts in this region. Okay, that's what. So now you can see that, now you can understand that by giving these contacts, I can see that in solution, first 6 modes are not a 0. That means I given the fixed support over here, and the contact between this two-dimensional mesh as well as one-dimensional, it is there. If you see the mesh structure itself, you can see that in the rectangle, right, there is a center, there is only x mark is there, right? So here in all triangular elements are formed at the center point, only that one dimensional element is connected. So the one dimensional element is there one from the center point only it is connected. So we have the uh, mesh connectivity over here. So previous and all, like before, I'm not giving the share topology. What will happen means I can see only the rectangular one. I'm not having this type of mesh is over there. That's what I'm getting. First 6 nodes are 0. Now I'm having the proper connection between the 1D and 2D. So I'm getting the 6 mode shapes I'm getting. Okay, so this is what very important, why mode shape is very important. Like by performing the model analysis, we can able to see whether we are apply the proper boundary condition or not, and we have to check whether have the connection, so the connectivity or mesh continuity and all is there or not. Okay, so this is the importance of model analysis. Hope you all understand the concepts. Okay, if you are getting any useful information from this video, uh, like this video and share with your friends. Thank you.